My name is Prithvisha Nath and I am the TA for this course, Engineering Mechanics. I am a PhD student in the Department of Aerospace Engineering at IIT Madras. So this is week 10. Let's start solving some questions. An object moves with constant velocity along a straight slot when the slotted disk rotates with an angular velocity as shown. The path traced by the object would be so the answer to this question will be spiral. Now the second question. Persons B and C each throw balls as shown while are sitting on a disc rotating in the horizontal plane with a constant angular velocity. So two persons are sitting at points B and C and they throw balls as shown by the arrows. So which one is correct? Option D is correct. Which of the following statements is or are correct? The Coriolis component of acceleration of a pin moving along a slot in a rotating member is invariably perpendicular to the slot. So this is correct. The rotation of Earth hardly affects the analysis of motion of cricket balls. This is also correct. For the analysis of motions of intercontinental ballistic missiles and spacecrafts, consideration of Earth's rotation is essential. This option is also correct. Natural phenomena like cyclones and trade winds are affected by Earth's rotation. So this is also correct. So all the four options are correct for this question. Now, moving on to the next problem. The collar A moves to the right with speed of 7 meter per second, which is increasing at constant rate of 3 meter per second square, both measured relative to the loop. While the hoop rotates with angular velocity and angular acceleration as shown, determine the following quantities pertaining to the collar. So this is the collar, and the speed of the collar is given as 7 meter per second, and which is increasing at a constant rate, which means its acceleration is 3 meter per second square, which is measured with relative to the hoop, and the hoop rotates with the angular velocity of 5 radians per second, and the angular acceleration of the hoop is 2 radians per second square. Now they have asked, now the question is the magnitude of the absolute velocity of the collar is. So what is given in the problem? So I'll attach both the frames here. this is y, this is capital X. Also rotating frame, I'll consider here this only. So what is the magnitude of the absolute velocity of the collar? Now what is given in the problem? Given v relative is 7 meter per second, a relative is 3 meter per second square. Now I'll just write down the formula. VA equals VA plus VO equals to VO, sorry, plus omega into R, omega cross R plus V relative, right? Now this velocity VO is 0 according to the choice of frame that we have considered here. So VO is 0. What is omega? Omega is 5 radian per second, right? So VA equals to omega is 5k cross R is what? R is 550 into, this is given in millimeter, so we have to convert it into meter, and this is minus of j, right? So minus j plus V relative is 7I, right? Now we just need to calculate this. Now this is IJK this will be 5 into 550 2.75. This is 2.75 I plus plus 7I, that is 9.75I. So VA is 9.75I meter per second. So this is the absolute velocity of the collar. So the magnitude of the absolute velocity of the collar is 9.75 meter per second. So moving on to the next part of the problem, the magnitude of the acceleration of the collar as measured relative to the hoop. So how should we calculate this? So A relative. So first we will calculate the normal component of the relative acceleration. That is nothing but v square by r. Now v is given as, v is already given in the problem, which is nothing but 7 meter per second. So 7, and r is 250 millimeter. So this becomes 196, and the tangential component is given in the problem, which is 3 meter per second square, right? So this is 3 meter per second square. Now we need to find the magnitude of the acceleration. So the magnitude is 196 square plus 3 square. This becomes 196.02 meter per second square. This is the answer. Now, next part of the problem. We are asked to find the magnitude of the Coriolis acceleration of the component. So, magnitude of the Coriolis acceleration of the collar to omega v rel. So this is 2 into omega. What is this omega? Omega is given as 5 radian per second so this is 2 into 5 and VREL is 7, right? So this becomes 70 meter per second square. So this is the answer to this part of the question. Now, moving on to the next problem. Crank CD is having constant angular motion as shown at the instant depicted. Answer the following questions with respect to the XY coordinate axis attached to AB, whose positive directions are shown. So the crank here is CD, which is rotating at an angular velocity of 1.75 radians per second. It can be seen from the question. And the XY coordinates are mentioned in the problem. So using this as the reference, we need to answer the questions. If Vc is the absolute velocity of the collar collar at c in meter per second, then x component of Vc. Now what is VC? VC can be written as 1.2 omega cross R, right? Omega cross R. So that is omega is 1.75 into R is 1.2. So this becomes 2.1 meter per second. Now we are asked to find the x component of VC. That is VC with respect to this xy coordinate, right? So from this triangle we can see that since this is 60, this angle is 90, so this angle would be 30, right? So the x component, therefore VC can be, how can you write VC? VC can be written as 2.1 into minus 30 sine 30 I cap plus this will be cos 30, right? Cos 30 j cap. So therefore the x component of VC is 2.1 into sine of 30 degree, that is 1.05, so minus 1.05. And for the next part we are asked to find the y component of VC. The y component of VC is nothing but this part, the j term, that is 2.1 into cos of 30 that is 1.82. So this is the answer and this is the answer. The magnitude. Now moving on to the next part of the problem. Magnitude of the angular velocity in radian per second of link AB. So how can we solve this problem, this part of the problem? So for this, from the previous part of this question, we found out VC can be written as 2.1 into minus 30 sine 30 I cap plus cos 30 j cap, right? Now uh, we can easily say, since this is this V relative will have motion in only in y direction, right? The relative motion V relative will only be in y direction. This we know. So I can write V rel to be j cap, right? Now I will simply write this in terms of components, like on the both sides. So V rel is this one. Now I'll just write in component form. VC equals to VA plus omega AB cross R AC, right? Plus V rel. Now VA is 0, right? So I'll just equate the components on the left and right hand side. Now I'll just write it. Equals to omega AB RAB I cap plus V rel J cap. Now comparing both sides, so 2.1 into sine of 30 degree minus 1.05 I cap plus 1.82 J cap equals to, so RAB is nothing but 1.2, so omega AB into 1.2 I cap plus V rel J cap. So we are asked to find out the angular velocity. So to find out angular velocity, we need to compare the I terms on both sides, right? So we are just asked to find the magnitude. So we can ignore this minus sign. Uh, Rather, we have this minus sign here also. So, yeah. Omega, yeah, we have minus sign here. Sorry, we have minus sign here because omega AB and RAC is in the I direction, right? Uh, Sorry, RAC is in the J direction. Sorry. So, uh, yeah. Yeah, omega AB is in the K direction and RAC is in the J direction. So this will be minus I, yeah. So equating, comparing both sides, 1.05 equals to omega AB to 1.2, right? So omega AB will be 1.05 divided by 1.2. So this will be 0.875 radians per second. So here we got omega AB. Now what we need to find out next is magnitude of velocity in meter per second of collar C as perceived by an observer rotating with link AB, right? So basically we need to find VREL. So what is VREL? VREL is nothing but, we need to compare the J terms here, it's nothing but 1.82. Now the next part of the problem. We need to find the Coriolis acceleration of the collar C in meter per second squared. We just need to write down the formula for Coriolis acceleration. So the Omega is what? We already found it. So that is 0.875, right? And that is in k direction. And V relative is in the J direction. That is 1.82 J cap. So this will be minus of 2 into 0.875 into 1.82. That is 3.185. I cap. So this is the answer. So we are asked the y component of Coriolis acceleration. So we can see it's just the component is only in the x direction. There's no component in the y direction, so it will be 0, right? Now the next part of the problem, this is a new problem. A disc rolls without slipping with a constant angular velocity as shown with a pin at P that slides along the slot in member QS. Based on the data given, answer the following questions with respect to xy coordinate axis given in the figure. So this disc is rolling without slipping with an angular velocity of 2.5 radian per second, and it slides along the slot in the member QS, and the coordinate axis is shown in the figure. So as per this diagram, we need to find out the given questions. Answer to the given questions. If RPQ represents the position of pin P in meter relative to Q, then the x component of RPQ. So what is the x component of RPQ? It's nothing but this distance, right? 1.25. It's along x-axis only. So it's nothing but 1.25. Now they have asked for the y component of RPQ. So this is only along x direction, right? So there is no component along the y direction, so it will be 0. Now what they have asked is, if Vp is the absolute velocity of pin P in meter per second, then the x component of Vp and the y component of Vp. So how can you write this? Vp is nothing but Vq plus omega cross r plus V relative, right? Now Vq is nothing but 0. So what is the next step? Also, we can find out this angle theta, right? So this total height is nothing but 0.75 meter, because the radius is 0.5 and this distance OP is nothing but 0.25. So the total distance is 0.75 and we know the distance PQ. So we can easily find out theta, right? So sine theta, we can find out theta from sine. So perpendicular distance is 0.75 and the hypotenuse is nothing but 1.25, right? Therefore this becomes 36.87 degree. Now I can write, they have asked the x component of Vp. So x component of Vp is nothing but 1.875 minus of 1.875 cos 36.87. So this will be minus 1.50. Now the next part of the problem, y component of Vp. The y component of Vp is 1.875 into sine of 36.87. That is 1.12 meter per second. So this is the y component of Vp. Now the next part of the problem, the magnitude of angular velocity of member QS in radian per second. So this is the member QS. We need to find out this angular velocity of this member QS. Now I will write Vp in component form and then equate compare I and j terms on both sides of the equation. So minus 1.50 I cap plus y component is 1.12 j cap, which is equal to omega cross r j cap plus v rel I cap, right? R is nothing but 1.25. I'll substitute this. So minus 1.50 I cap plus 1.12 j cap equal to omega. No, this is just magnitude. Yeah. So this will be 1.25 omega j plus vrel we need to find out. So comparing both sides, rel is nothing but minus 1.50 and 1.12 equal to 1.25 omega. So omega is 1.12 divided by 1.25, which is nothing but 0.896 radians per second. So now the next part of the problem, the magnitude of velocity of pin P in meter per second as perceived by an observer rotating with QS. So this is nothing but V relative, right, which we already found out. So this is V rel, which is minus 1 point. So they have asked for the magnitude, so this will be magnitude of velocity of pin P as perceived by an observer rotating with QS will be V rel, that is 1.50 meter per second. So this is the answer. So for the first question, an object moves with a constant velocity along a straight slot. When the slotted disk rotates with an angular velocity as shown, the path traced by the object would be, so the path traced by this object would be obviously spiral, right? And for the second question, two persons B and C each throw balls as shown while sitting on disc rotating on the horizontal plane with constant angular velocity as shown. So D is correct. Which of the following statements is or are correct? The Coriolis component of acceleration of pin moving along a slot in a rotating member is invariably perpendicular to the slot. So this is true. Now the rotation of Earth hardly affects the analysis of motion of cricket ball. This is also true. For analysis of motions of intercontinental ballistic missile and spacecrafts, consideration of Earth's rotation is essential. So this is also true. And the last option is natural phenomena like cyclones and trade winds are affected by Earth's rotation. So the fourth option is also true. So all four options are correct in this question. Now in the next question, the caller A moves to the right. This is caller A, which is moving to the right with a speed of 7 meter per second and which is increasing at a constant rate of 3 meter per second square, which is nothing but the acceleration, and this is measured relative to the hoop, right? While the hoop rotates with angular velocity and angular acceleration as shown, determine the following quantities pertaining to the caller. Now omega and alpha is given. Omega and alpha is given for the hoop, and the speed and acceleration of caller with respect to the hoop relative to the hoop is provided in the question. Now we are asked to find out the magnitude of the absolute velocity of the caller. Now we have attached the frame of reference as follows, as can be seen from the diagram. So I just I have written down the formula here. VO is 0, right, as per the choice of the frame of reference, and omega cross R I have substituted omega as 5, and it is in K direction, and R is in minus J direction. So ultimately this quantity becomes I in I direction, and V relative can be seen, it is in the I direction, right? So ultimately solving this gives VA to be 9.75 meter per second, which is in the I direction, that is in the X direction. So the magnitude of the absolute velocity is nothing but 9.75 meter per second. Now in the next part of the problem, they have asked for the magnitude of the acceleration of caller as measured relative to the hoop. So there are two components, right? One is the normal component and one is the tangential component. So the normal component is V square by R, and V is given as 7 and R is 250 millimeter. It is also given in the problem, so we have to convert it to meters. So ultimately solving this gives 196 meter per second square. And the tangential component of acceleration is also mentioned, which is nothing but 3 meter per second square, right? So the magnitude of the acceleration becomes 196.02 meter per second square. Now they have asked for the Coriolis acceleration. So that is 2 omega into v relative. That is 2 into 5. Omega is given as 5 and v relative velocity is 7. So that becomes 70 meter per second square. Now moving on to the next problem. The crank CD is having constant angular motion. As shown at the instant depicted, answer the following equations with respect to the xy coordinate axis attached to AB whose positive directions are shown. So from the problem, from the given diagram, we can see omega is 1.75 and length CD and AC both are 1.2 meter. Therefore, and they have also mentioned Vc is the absolute velocity of the collar in meter per second. So we need to find the x component of Vc. So we can write Vc in other component form, and first we find out Vc. What is Vc? Omega is given, and we know R also. So it is nothing but 1.75 into 1.2, which is 2.1 meter per second. Now I need to write in component form in the xy coordinate system, right? So this angle we can easily find out, which comes out to be 30, right? Because we know this angle ACD is 60 degree and VC is making an angle 90 with the CD. So this angle, the remaining angle is 30 degree, right? So VC in the xy coordinate becomes 2.1 minus of sine 30 because it is in the opposite direction, right? And y component is cos 30. So the x component is 2.1 into sine 30 and there is a negative sign. So minus 1.05. And the y component is nothing but 2.1 into cos 30, that is 1.82. Now they have asked to find out the angular velocity in radian per second of the link AB. Now I have already written down BC in terms of its component, and I know V relative is in this J direction, right? So I'll write down the formula. So VA is 0 and omega A RAB, we know RAB. And we know V relative is in the J direction, right? So we just now RAB is 1.2 and we just compare both the sides, like compare the I and J components. So first, if we compare the I components, from there we get omega AB, which is nothing but 0.875 radian per second, and relative velocity is nothing but the J component term, right? So that is 1.82 meter per second. Now they have asked to find out the x component of Coriolis acceleration. Now Coriolis acceleration is 2 into omega cross v relative. So so which turns out to be 3.185 I. So in from this we can conclude that there is no component in the j direction, right? So x component is 3.1 minus 3.185 and the y component is 0. There's no component along the y direction. Now the last problem. Here a disk rolls without slipping with constant angular velocity with a pin that slides along the slot in member QS. Now based on this given data, we have to answer the following question with respect to the xy coordinate axis. So they have already mentioned the xy coordinate and the distance PQ is 1.25, and from the given figure I can say that this total distance is 0.75, right? This distance is 0.75. Now they have asked, so they have mentioned that R PQ represents the position of pin P in meter relative to Q. So the x component of RPQ. This distance PQ is along the direction x, right? So the x component is nothing but 1.25 meter. Now, so we can as we can see that this uh, there's no component along y direction, so it will be 0, right? Now the next part of the problem, if Vp is the absolute velocity of pin P, then x component of Vp. Now first we need to figure out what is theta. Theta is nothing but let us assume that this is theta. So I know the distance PQ and I've already found this distance 0.75 meter. So from sine theta's formula I can find out theta. That is sine inverse of 0.75 by 1.25. So this comes out to be 36.87 degrees. Now from there we can find out the x component and y component of Vp respectively. So the x component of Vp is nothing but one 1.875 minus of cos 36.87, which is nothing but minus of 1.50, and the y component of Vp is 1.875 into sine 36.87, that is 1.12 meter per second. Now we need to find out the angular velocity. Now this is same like the previous problem, we just need to compare the terms on the left and right hand side. So I will write Vp in terms of I and j components, and then on the right hand side I'll write omega into r, which is in the j direction. and V relative is in the I direction, right? Now I'll just compare both sides. So V relative becomes minus 1.50, and to find out omega I need to compare the J terms, right? So by comparing I get omega to be 0.896. So this is what they have asked, the magnitude of velocity as perceived by observer rotating with QS, which is nothing but the V relative. So this is what they have asked. So these are the problems that we solved this week. So we shall we will stop here then.